Okay, dear friends, now we are going to the second overview, how to import the 3D models in the Ansys Workbench. Okay, so now I'm going to the Ansys software. Okay, here is the geometry. You can be directly double click in and enter into the geometry design modelers modes, or maybe let's wait. This one is a space climb software, okay, which is inbuilt into the Ansys. There is a two types of modeling environment is here. One is a space climb, which is a more effective utilization CFD analysis point of view, and second one is for design modelers, which is a very nothing but similar um, to the overall general practice. So you can be right click and insert into the new design modeler geometry. Here you can be see there's a number of tools is there. Okay, here is a xy plane, then this one is zx plane, this one yz plane. Okay, you can set the units types here, for example meter, centimeter, millimeter, micrometers, foot, inches, and it depends, but generally we are here following the millimeters. Okay, if you require the tolerance type, you can be select loose, normal, and tight as per your requirements. Okay, now we'll show the how to import the 3D models, because we are already ready in the SolidWorks files where we converted into the step files. Okay, so right click it, import geometry, or some browse. So in browse models we can be check where is our file is present. So WIF, for example 12063, 29 floating hydraulics, we can be select Control C, and here is Control V. Okay, here we can be change the file type. For example, we require the step files. So there is a with rollers and without roller two files is there. So first I select this one files. So open. If you saw after getting the 3D models into the geometry, here the tick mark is coming. So what is mean by this one? So it is mean it is up to date. Okay. So in geometry, for example, if you require some modifications or selections, so you can uh, right click it and edit geometry in design modelers. Here is options is required. It is main key, it is required to generate. So just do it first generate. Okay. Here is a simplified geometry. You should on yes. For example, simplified topology. Please convert into the yes format. Then again generate it. Okay. Here is simplified geometry. You can directly select the both complete cylinder surface as coming in single selections mode. Okay. Now we'll see how much body is coming. So we can be select by selection. And this one is the point selection, this one is the line selection, this one is the surface selections, means area selections, and this one is the body selections. So okay, I will go select to the body selections method and finding how much body is there. 1, okay, 2, 3, and 4. Okay, but we know okay, all these are become the one body after welded. Okay, same here, 1, 2, 3, and 4. Okay, and this one is for tie rod. Okay, understand? Now what I do here is we can be convert all this body into the single body. So what will be the tool I can be use? So here's the option is there. For example, boolean first, second, third, and fourth, and apply it. It will be the convert into the generator. Here you observe previous is 9 bodies showing, right now is converted into the 6 body, means all these bodies become the all four bodies become the single bodies. Same operations we'll do here again. So where I go, create boolean first, second, third and fourth, then apply and generate. Understand? So now body is converted into a three bodies only, first, second and third. Okay, right now here is my geometric linear process is completed. Now I'm switching into the meshing point of view. Okay, close design modulus, then models, edit. It is taking the minimum times. Now first understand what is the tree structure of this one. Okay, here is a geometry where is defined the structure steel. I am selecting the normal structure steel, means normal structures means they are following the IS 2062 grade B materials. Okay, same here, same here. Okay, here is the materials properties here. Okay, structure steel, all detail is you can be found it here. Okay, now here is the connections. So here is a contact region between the two bodies. For example, first body this one, okay, and second this one. So all this is bonded region, and second again, because here is the three bodies is there, so there is a two contact will be the coming because towards the sharing the same face. Okay, it is a too much details. For example, if you study because there is a number of types of contact is there. Okay, so here is the connections in contact bonded, no separation, frictionless, friction and generally for example welded structures is there, bolted structures is there, you can be use a bonded. For example, if the part is gliding onto the any surface, you can be select the frictions, so you can be give the frictions value as same as frictionless and no separations and rough. Okay, again there is a connections in for example multi-body dynamics analysis, you can be go, there is a number of types of body with ground conditions and body to body connections. Okay, it will be more useful in the kinematics or non dynamic analysis point of view, but here is the models of what is the structure analysis point of view, so we can be select off here. Okay, now already I did this analysis, I think 3 to 4 days earlier, and sharing the same information to the my teams. Okay, so we'll check analysis reports because already I did the complete 12,063 web guide bracket analysis. Okay, okay, there is a 3D models we just find. Here is idler conditions, this one is the web guide rollers, then materials, bracket materials consider as a structure. See what I already show you. Here is the locations of this spring. Okay, unwind tension zone is 50 to 400 newtons. Okay, idler roller case this one, then tension act upwards because for example wave is passing these directions and going to the upward side, so means this will be the upward tensions, and this rollers is going downward directions because the force tensions is coming from top and pushing to the downward directions. Okay, so web guide rulers is 9.05 kg, idler rulers weight is 8.63 kg. Okay, so now we convert this one into the meshings. For example, mesh here element size I consider is 3 mm. Okay, generate. Okay, if you observe our body is completely mesh, right? This one is a tie rod, Okay, in meshing there is more than 84 types of meshing is there in Ansys Workbench itself. So it is depends your requirements, you select the types of machines and conditions. For example, insert method, for example, you require some refinements, so you can be just select the surface. For example, I require the refinement on this zone, okay, and apply. For example, you can increase, then generate it. You observe, for example, here is a 3 mm, but after refinement you're getting the fine result on this one. Okay, observe it. So in meshing selections point of view, we are giving the fine results where the shapes and geometries are very important. So maybe where the reactions forces are coming too much, or where we need to designer should be take the actions against the same surfaces. Okay, you can be cut it as per requirement. For example, if you want to show it, see it, for example, sections plan is there, you can just cut it, drag and drop. And here you can be check, here is a option is to show elements, so you can be check the elements types. For example, this, okay, there is a fine result, that's why this one is just showing the more fine elements. Outside geometry is the most coarse elements. Okay, understand? Now I'm deleting this one because this is not important for right now for me. Okay, now here's all conditions we are applied. Okay, now we go to the static structures point of view. Okay, so in a static structures point of view, for example, where is the fixed point is required. For example, if you observe into the or so bracket is a fix at this one at, okay, is these locations. Hmm? So, my dear friends, mostly designers are picking these cylindrical surfaces, but it is not true because we are generally locking the washer face because of initial pressures of bolt tightening is acting on the surface of this geometry, not the cylindrical surface. Understand? So I am picking this one. So don't get confused. Okay, first, second, third, and fourth, and right click it. You can go to give to the fixed support. Understand? So this fixed support is coming. You can be give second options, you can give this one from these directions and select 1, 2, 3, and 4. Okay, selections apply. Understand? Now again, if you observe again, this is a question mark is coming. So what does this mean? It is meaning you require some forces or some extra forces constraints to here. Then after your equations will be complete. Okay, because you know the we already spoken to the Gornick equations. So K is equal to U and is equal to F. K is the stiffness of the matrix and U is equal to displacement and is equal to F means forces. Okay, so here is a force is pending right now. So already we get what is the web tensions, web guide rollers. So web guide rollers is force is coming downward direction. So what is the self at the web guide rollers is 9.5 kg, means we can be saying it is at it is conversion. For example, 9.05 multiplied by 10 is near about 90. We can be assume is 100 newtons, and as well as we require to take the tensions of the unwind tension zone is 400 newton is maximum directions. Okay, so here again I will insert the remote force. Okay, first this one and second this one is apply. You can expand here by vector instead of components. So in minus directions, because the y-axis is upward showing, so it is value will be the going to minus. For example, minus 100 newtons for the self at the web rulers, 450 400 newton is the web tensions. So all is becomes a 500 Newton, but multiplications by 2 times for factor of safety. So I am giving the 1000 Newtons approx. So if you observe, here is the my constraint, my body is downward directions, so force is coming downward directions. Again, second wave tensions will be the coming onto this rollers, which is the upward directions. Okay, so again we go to the again. So this one is going upward directions. So idler roller weight is 8.6 kg, means 90 newtons, plus 400 newtons of wave tensions is 490, multiply by 2 times, means 980 newtons. So again I provide the insert remote force. First, second, apply. Instead of vector we go to the components, and 980 newtons is upward direction. So here is the result is upward. We can select both and see, one is directions is going downward directions, while second one directions is coming upward directions. Okay, now it is time to calculate the over total deformations and over stress, equivalent man masses stresses. Okay, now solve it. And let's check after solving it is taking maybe 2 to 3 minutes for solving of all these equations. Now here is showing 41 deformations is coming, approximate maximum deformance 0.042. Here we can insert the maximum limit, so we get the maximum. Okay, we can insert the minimums. Okay, here is a probe method is going on, you can be click and you can find out. So we okay, now equivalent stresses, where is the maximum point is coming, so it is showing the maximum here. Okay, so in machines you can be go and give the some refinements, you can be give the some fillets to improve the weld, improve the geometries, because here is a stress line is coming directly perfectly 90 degree, so which is not suggested by designers. So here already we know we are putting the here the welded structures is for example, if you want a more deep study, you can just provide in the weld thickness into the 3D models and import the same into the Ansys, so you will get the better result. Okay, now we move on. For example, so first we want to know what is the factor of safety, because the factor of safety is very important to know for example how much part is safe. So insert stress tool, maximum equivalent stresses, it will show the safety factor, just solve it. Here we getting the approximate minimum 5.9908 minimum factor of safety, and maximum is showing 50, means it is the infinite life of the body. Okay, understand? So due to these methods we are finding that brackets are safe or not. For after getting this result, we are know that these brackets are safe and we can be used in our practice in our machines, so there is no problems with the face. Same we are using these brackets right now in 12,063 machines which are upcoming in the project of the projects may. Okay, so thank you for watching this one. We'll meet in the next video for to understand the what is the fatigue life. Okay, thank you.